subscribe and turn on the notifications to get more freshly brewed content from us.
Welcome all. This is the first official video from Sci-ctory, and if you haven't seen the intro video, this channel is completely for CIE, AS and A-level IGCSE students. For today, we will be looking into AS level Physics Unit 1, Physical Quantities and Units for the improvised syllabus which is from 2022 to 2024. So let's not wait and get into the video. I think you all can see the table of content. We will be starting off with physical quantities, continue with SI units, then uncertainties and errors, and signing off with scalars and vectors. For every single construction or plan, we need to take measurements, and each measure has a physical quantity like length or mass. All physical quantities consist of a numerical quantity and a unit, and the units are represented by alphabets. For instance, a rope has a length of 9 meters. In this case, 9 is the numerical magnitude and m is the unit of the meter. So here we can see some estimates for physical quantities. I say it again, these are just estimations. You can take a screenshot of this or just snip it. Or if you wish, you can even note it. I guess now everyone are ready to view the next slide. Jumping on to SA base units, these are units from where other units are derived from. We say these are parental units. These are important, so it's better for you all to note it down. Unit of mass is kilogram, unit of length is meter, unit of time is second, unit of current is ampere, unit of temperature is Kelvin, and not Celsius. This is an important point to note. Unit of amount of substance is moles, and unit of luminous intensity is candela. The next is derived units. These originate from calculation of base units. It may be multiplication or division. For example, the derived quantity force has special unit Newton, but whereas it has the base quantity of kg meter per second square. Because we all know that the equation of force is equal to mass multiplied by acceleration. Mass has the unit kg and acceleration has the unit meter per second square. Then the next topic may seem difficult, but it's actually very simple. For an equation, first step, write down the base quantities for both sides. Then step 2, check whether both the right hand side and left hand side of equations have same basic units. If yes, the equation is homogeneous. If not, try balancing the equation to get same units on both the sides. Powers of 10. Here we have different prefixes and we have shortened all descriptions into a small list. If you wish, you can note it down. I think now we are good to proceed. Here comes errors and uncertainties. Now the third partition of Unit 1. Hold on guys, we still have just two more to go. Errors are of two types, systematic and random. Systematic errors are caused by faulty equipment or imprecise measuring equipment. Zero error is one such type of systematic error. This type of error cannot be eliminated by taking average, and more importantly, this affects the accuracy of the results. Then comes the random error. This error is unpredictable and usual errors which we all experience, like counting mistakes or parallax errors. These can be eliminated by taking average, and random error affects the precision of results. Here comes accuracy and precision. Accuracy measures how close the results are with the original value, and precision measures how close the results are with each other. In the first case, all the results are closer to each other and are closer to the original value also, so they have very high accuracy and precision. In the second case, the values are closer to original value but far away from each other, so it has high accuracy and low precision. In the third case, results are close to each other and far away from the original value, so they have high precision and low accuracy. In the last case, the results are far away from original value and even far away from each other, so it has low accuracy and low precision. We cannot have all answers very accurate or very precise. There may be small fluctuations in the results, and we may be uncertain about whether the reading should be represented with a plus or minus. We have three types of uncertainties: absolute, fractional, or percentage. As the name suggests above, absolute uncertainty is fixed form of uncertainty. Fractional uncertainty represents uncertainty in a form of fraction, and percentage uncertainty is shown as percentage from 100. In the first picture, you have the method to convert the absolute uncertainty to fraction uncertainty, and vice versa. Also, you have the method to convert percentage uncertainty to fractional uncertainty, and also the vice versa. In the second picture, which gives you the clear idea of how to represent the uncertainty in significant figures and decimal places. For numerical questions involving uncertainties, here are the procedures. For addition, add the absolute uncertainty. For questions involving multiplication or division, add the percentage uncertainty. For questions involving powers, multiply the power with the percentage uncertainty and finally add them. The next is scalars and vectors. This is a well known topic. Scalar quantities consist of numerical magnitude, but vector quantities, on the other hand, have both numerical magnitude and direction. And a small note, vectors are represented by arrows. Addition and subtraction of vectors. When the arrows join from tail to tail, you can draw parallel lines to form a parallelogram, and the diagonals passing will be the resultant vector. This is a parallelogram law. In the case of triangle law, the tip and tail of vectors join the line joining the ends of the vectors tend to be the resultant vectors. These two laws will be followed the same in both addition and subtraction of vectors. A small change should be done while subtracting the vectors. The direction of vectors should be reversed. Then one more important note is that forces acting on the same place can be illustrated as vectors. When three of these vectors are combined together and when they are equilibrium, they form a vector triangle. Next comes the resolving vector. Two different vectors can be illustrated as a single resultant vector, and also a single resultant vector can be resolved and illustrated by two vectors. This leads to the formation of components. Components are single result vector which is broken into two parts. A vector always has two perpendicular components, a horizontal component and a vertical one. To calculate the horizontal component, we use the formula f cos theta. For the vertical component, we use f sin theta. So finally, guess what? We have successfully completed the first unit from Physics AS level. We have attached the notes for this unit in the description box. So keep learning with us and support us by subscribing and commenting on our videos. Waiting for your comments. Until then, we are signing off for now. Meet you all in the next video.